Basic
Education,
Math
Teacher Society.
Basic Education Math Teacher Society.
To encourage and stimulate excellence in mathematics and its application by conducting seminars and workshops for mathematics teachers.
To encourage and provide opportunities for the exchange of ideas and materials related to instruction of mathematics by holding annual research conferences.
To further the cooperative study of problems related to the teaching of mathematics and the basic education by promoting action-oriented studies and
work for the improvement of mathematics and instruction at all levels of education by holding fora and symposia for experts in the field of education and math teachers exchange relevant dialogues.
In line with the organization's tagline and objectives, the organization holds the following activities, but not limited to:
research conference, summer workshops, trainings, action research projects, forum and symposium, needs assessment, and quiz week.
benefits of the members.
Certificate of membership with unique membership ID number.
Discount on training and research conference fees.
Priority on special trainings sponsored by the bmts.
Priorities on events and activities sponsored by bmts.
Opportunity to join or collaborate research projects, and opportunity to be appointed as speakers in trainings and seminar workshops sponsored by bmts. In order to achieve our main objectives, we aim to hold seminar workshops and trainings for math teachers, hold research conferences, conduct collaborative researches with math teachers in the Philippines, and hold symposium, fora, where field experts in education and math teachers exchange relevant dialogue. For membership details, contact any of the BMTS officers or BMTS division representatives.
Good day to all our viewers watching live from MTM channel, the official YouTube channel of the Mathematics Department of Schools Division Office of Mandaluyong City, as well as to our Zoom live viewers for today's session. Welcome to the second day of the 3-day National Seminar Workshop on Conducting and Interpreting Factor Analysis in line with the celebration of National Teachers Month. This is a webinar series conducted through the initiative of Basic Education Mathematics Teachers Society Incorporated in collaboration with Schools Division Office of Mandaluyong City, Marikina City, and Parañaque City. I am your host for today, Sir Ray Collado from Highway Hills Integrated School, DepEd, Mandaluyong City. Before we proceed with our program, let us have a few announcements. Next year will be the 2022 Basic Education Mathematics Teachers Society International Research Conference, which will be held virtually, having the theme Connecting the Links of Science, Technology, Engineering, and Mathematics for an Enhanced Mathematics Teaching Learning Process in the New Normal. The 2022 bmts Research Conference is open to any interested mathematics enthusiasts, which range from undergraduate to postgraduate and graduate students, professional teachers, to the mathematics researchers. This conference is an opportunity to learn, discuss, and collaborate with fellow mathematics education researchers. The schedule and venue for this 2022 bmts International Research Conference would be on January 27 to 29, 2022 via Zoom platform. This is co-organized by Department of Education Region 7, St. Paul University of Dumaguete, and Negros Oriental State University. The 2022 conference activities would include the following. First is the plenary sessions. Second, research paper presentations. Third, demonstration teaching. Fourth, workshops in mathematics teaching and learning. And fifth, Math Calculympics. To those who wish to present their papers, workshop, demo teaching, submit your abstract through the Google form posted on their Facebook page, the BEMTS Inc. Again, their Facebook page is BEMTS Inc. The abstract is composed of 250 words and should be informative for proper evaluation by the program committee. Participants will be notified for possible acceptance as soon as possible. The deadline of submission is November 15, 2021. For additional information and further directions, please email Dr. Rodolfo T. Onzo Jr., the President of BEMTS Incorporated, and Dr. Craig N. Refugio, Vice President for Research and Extension of the same organization. Their emails are posted on your screen. Also, for other details, you may contact the coordinators from our co-organizing teams. The names and cell phone details are posted on your screens as well.
Again, a pleasant morning to everyone. The details of the attendance will be sent on the chat box. Please accomplish the day 3 attendance in the chat box for your certificates later on. Please be reminded that all the certificates will be sent only if you have attended the 3 days session with us. Thank you very much. So to formally begin our program, let us all sing the Philippine National Anthem. And after that, let us offer our prayer to our Almighty God.
mga kababayan, ang pambansang awit ng Pilipinas.
Dear God, thank you for the opportunity to meet together. Please help us to come together to make this institution reflect your kingdom. Breathe life into our ideas and decisions. Help us build a team that has love and respect at its heart. Give us the strength to continue working for your kingdom in this time of pandemic. Lord, come give us the inspiration to be the best we can be. May we be a shining example of your goodness and truth within, wherever we are. Inspire our thoughts, discussions, and ideas, and continue to remind us that all that we do here today, all that we accomplish, is for the pursuit of truth for the greater glory of you. We ask these things in your name. Amen.
Again, a pleasant morning to one and all. Kindly accomplish the attendance link that is already sent on the chat box. Again, for those who have just entered, the attendance link is already sent in the chat box. Thank you very much. To formally welcome us to this third day of this 3-day national seminar workshop on conducting and interpreting factor analysis, let us welcome the PIO for International Schools of BEMTS, Ms. Ritzel Muntalban.
Buenos dias, magandang umaga. From the land of the free, good morning, educators, researchers, and everyone around the world. I thank you all for your continued support and active participation starting from day 1 until today. I would like also to recognize and thank all the people behind this successful event. This webinar is made possible through the efforts and collaboration of the officers of BEMTS, Basic Education Mathematics Teachers Society Incorporated, and the Department of Education Schools Division of Mandaluyong, Marikina, and Parañaque. In any research, interpretation of data and using the appropriate statistical tool is necessary to produce a reliable and scholarly academic research output. This 3-day webinar will give you an opportunity to explore more on factor analysis. Previously, the theories of factor analysis as well as exploratory factor analysis technique was thoroughly discussed. Today, you have another technique which you will explore more on confirmatory factor analysis. Without any further delay, I welcome you all to our 3-day webinar. Enjoy and have fun while learning.
Thank you very much, Ms. Ritzel, for that warm welcome. At this juncture, ladies and gentlemen, let us have the main session for this day. Let me introduce to you our speaker for today. Our speaker finished his BSI Ed Math cum laude in 2003 and MAT Math degrees at Palumpon Institute of Technology and the Doctor of Education in 2010 at Silliman University. He was an assistant professor in Mathematics Department of University of San Carlos, Cebu City. He handled business mathematics, advanced algebra, statistics, and many more. He also handled research and statistics classes at the senior high school of the same university. He presented and published papers on mathematics education and pure and applied mathematics in both local and international journals. He developed instructional materials for remedial math for subjects like college algebra and statistics and for primary subjects. He delivered talks on teaching techniques and strategies, art of questioning, workbook writing, assessment and evaluation, technology and research paper writing. He authored books in general mathematics for senior high school and teaching statistics and probabilities through activities. He is a national math trainer of the Private Education Assistance Committee, or PEAC. Also, he is an international mathematics education consultant of the Casio Gakuhan Education. He is an editorial board member of IJRDO, Journal of Education Research. He also served as reviewer of local and international journals. He is the president of the Basic Education Math Teacher Society Incorporated. He is currently an assistant professor at the Department of Teacher Education, Visayas State University, Isabel. Ladies and gentlemen, let us all welcome our speaker for today, Dr. Rodolfo T. Aunzo, Jr.
Okay, good morning, everyone. Welcome to our 3rd day of the webinar series on conducting and interpreting factor analysis. So this morning, we will be talking about factor analysis in structural equation modeling, meaning we are going to highlight how we are implementing or integrating factor analysis in structural equation modeling. First, let us talk about some basic concepts of structural equation modeling. Structural equation modeling is not just one statistical technique. It is actually a combination of different statistical techniques. So it basically includes factor analysis, regression or the correlation, and simultaneous equations. Factor analysis in the sense that we are going to evaluate the indicators or components of the factors. Regression or correlation because we are going to establish the relationship of the factors and the factors as predictors of another factors. Simultaneous equation because some predictors can also be an outcome variables which can be both functions, which can function both as independent variable or dependent variable. Then, in the basic, uh, in the basic structural equation modeling, we basically have two distinct models: the measurement model and the structural model. Okay. This morning, we will be discussing about the mediation analysis using the structural equation approach. So we will be introducing here a specific variable which serves as mediator of the relationship of one or of two variables. Okay, let's first take a look of this illustration. The relationship of two variables, the x as the independent variable and y as the dependent variable. In this illustration, x here is statistically or significantly associated with y. Now, in the mediation analysis, we practically form um, variables into a triangle. So there is still an independent variable and a dependent variable where x is significantly associated with y. In this relationship, we introduce the another variable, say variable m, which is a mediator variable found at the top of the triangle. In this note, x influences m and then m influences y. If x is significantly associated with y, and if x influences m and m influences y, then m is a mediating variable between x and y. That is according to Hombeck in 1997. What is mediation effect? The mediation effect is defined as the reduction in the regression coefficients of x and y when the effects of m are controlled for. If there is mediation, the effect of x on y may be reduced or totally vanished after m is controlled for. Significant effects are on x to m and m to y. So in this illustration or in this model, the relationship or the effects of x to y will be reduced or it may totally vanish if we introduce m such that x affects m and m affects y. So that is the concept of mediation analysis. So in this model at the top or left side, this is the unmediated model where x affects y, while this model below is the mediation model wherein the relationship xy is mediated by m. So in this model, mediation model, there is a significant effect of x to m and m to y, such that the effect of x to y is reduced or may totally vanish when m is integrated or when m is introduced in the model. Now let's look at this structure. The one in the red box, okay, the one in the red box is actually considered as the measurement model. The measurement model, so we have here the measurement model for the variable m, the measurement model for variable x, and the measurement model for variable y. So in this model, we are actually introducing the confirmatory factorial analysis such that we are trying to investigate if the indicators or the indicator statement x sub 1, x sub 2, and x sub 3 reflect that of the variable m. The indicator statements x sub 1, x sub 5, and x sub 6 reflect that of independent variable x. And the statements x sub 7, x sub 8, and x sub 9 are indicators of statement that of the dependent variable y. So we're going to use the confirmatory factor analysis to establish whether these statements are really, the indicator loadings of these statements are really that of their respective variables. Now look at this inside the red box. So this is now our structural model. The structural model in the sense that we are going to establish the relationship between the constructs or the variables such that x affects m, m affects y, and the effect of x to y is reduced upon introducing the mediating variable m. So this is our structural model in our analysis. Let us discuss some fundamental structural equation modeling terminologies. We have here the measured latent variable x or the m or the y. These are the latent variables. These three are the factors in our SEM analysis. While the x sub 1, x sub 2, x sub 3, x sub 4, x sub 5, x sub 6, x sub 7, x sub 8, x sub 9 are observed variables. So in this illustration, the x sub 1, x sub 2, x sub 3 are observed variable or indicator statements that will measure the m variable. While x sub 4, x sub 5, x sub 6 are indicator statements that will actually measure our x variable. And x sub 7, x sub 8, and x sub 9 are indicator statements that will measure the y variable. While the regression or directional path is represented by this arrow showing that x affects m and m affects y, then x affects y. I'm putting here a broken line to show you that if m is introduced in the structure, the effect of x to y is either reduced or totally vanished, because originally if there is no m or mediating variable, the effects of x to y is very huge, or there is a huge effect of x to y. But upon introducing the mediating variable, the effect of x to y is reduced or may totally vanish. Now let's focus on the observed variable. When you say observed variables, these are types of variables that can be measured directly, such as demographics, the age, the gender, the civil status, the religions. Observe the sample survey questionnaire below. Okay? The purpose of this statement is to validate the conceptual framework of relational constructs by testing the relationship between computer value belief, or the CVV, perceived peer support, or the PPES, and the confidence in using technology, or COT. So if you are going to put your male, so it will measure directly, or it will identify directly your gender. If you put here single, it will it will directly tell you your civil status. Okay, and so on and so forth. So that is observed variable. On the other hand, the latent variables are variables that cannot be measured directly, such that they need indicators in order to be measured. So examples of the latent variables are the computer value belief or CVB, the perceived peer support or PPES, the confidence in using technology or COT. In order to measure these variables, we need indicators or indicator statements. The sample survey questionnaire below show that the CVB has 5 indicator statements and the PPES have 4 indicator statements. So the direction is rate each item from 1 to 5 by using the following options. 1 is the strongly disagree, 2 disagree, 3 undecided, 4 agree, and 5 strongly agree. So the latent variable here is computer value belief, and the computer value belief will be measured by the following 5 statements. So statement 1, it is useful to me to have computer skills. Statement 2, I enjoy so much doing things with the computers that sometimes it is difficult for me to stop. Statement 3, it is important for me to be good at computers. Statement 4, it is important for me to improve my computer skills. Statement 5, most professional in the future will require computer. So these 5 statements are used to measure computer value belief. Okay? So we need these 5 statements in order for you to measure the computer value belief of the respondent. So these 5 statements are called indicator statements. And the computer value belief that is being measured by the 5 statements is the so-called latent variable. Okay, another example of the latent variable is the perceived peer support, which is measured by 4 statements. First statement is my friends are interested in computers. Number 2, when my friends and I get together, we enjoy doing things together on computer. Statement 3, my friends and I like to help each other on the computer. Statement 4, my friends and I enjoy talking about computers. So these 4 indicator statements are used to measure perceived peer support of the respondents. Okay, so our perceived peer support is now the so-called latent variable. Let's now proceed to the difference between reflective variable and formative variable because these are used in structural equation modeling. On the left side is the structure or illustration showing reflective latent variable, and the right side is a formative latent variable. So here is the construct or the factor or the latent variable, the construct. In this illustration, it shows that the construct affects the indicators. Okay? Construct affects indicator x sub 1. Construct or the the latent variable affects indicator statement x sub 2. And the construct or latent variable affects indicator statement number 3. So technically, in the reflective latent variable, x sub 1, x sub 2, x sub 3 are indicators that are redundant or highly correlated with each other. Say, for example, if the response of the respondent in statement 1 is high, then the response on the statement 2 is also high. If the response of the respondent in statement 2 is high, then the response of the respondent in the statement 3 is also high. So the indicator statements are redundant or highly correlated. So the latent variable causes the indicators. These are the 2 characteristics of reflective latent variable. Now for the formative latent variable, it's on the other way around. The latent variable is caused by the indicators, or the indicators causes the latent variable. Say, for example, x sub 1 in the indicator statement, x sub 1 causes the construct or the latent variable. X sub 2 causes x sub 3. X sub 3 causes, x sub 2 causes the latent variable. X sub 3 causes the latent variable. Okay? And the three indicator statements are not redundant or not highly correlated. Meaning to say, if x sub 1 affects the latent variable, it is not necessary that x sub 2 also affects the latent variable. It may be only x sub 1 alone affect the construct, or x sub 2 alone affect the construct, or x sub 3 alone affects the construct. So the three indicator statements are not highly correlated or not redundant. Okay? Again, the indicators affect the latent variable in the formative latent variable. Let us have a concrete example of reflective variable and formative variable. Okay, diet. So our latent variable here is diet. So diet affects, if you're on diet, it affects the indicator, I eat healthy food. So if meaning to say, if you're in diet, you will eat healthy food. Okay. If you're on diet, you do not eat much junk foods. If you're on diet, you have a balanced diet. Okay, so diet affects the indicator, I eat healthy food. Okay, diet affects your eating on the junk foods. Diet affects your balanced diet. So these indicator statements are caused by the latent variable diet. And there is also a high correlation among the three indicators, because if you eat healthy food, then there is also a high possibility that you do not eat much junk food and you have a balanced diet. Okay, so these three indicators are highly correlated or redundant. Okay. Informative latent variable, the statements affect the latent variable. Say, for example, if you have a balanced diet, then you will be healthy. Okay? If you exercise regularly, then you will be healthy. If you get sufficient sleep each night, then you will be healthy. So it affects your health. Okay? If you exercise regularly, then you will have a good health. If you have a balanced diet, then you will have a good health. If you get sufficient sleep each night, then you have a good health. Okay. So the indicators affect the latent variable health. Another example. Timeliness. So if you are timely, you accommodate last minute requests. If you are timely, you are punctual in meeting deadlines. If you are timely, you speed on returning phone calls. Okay? So, according to Holland in 1999, indicators must be highly correlated. So, meaning, if if the respondent rate high on this statement, accommodate last minute request, then the respondent will also rate high on the statement punctuality in meeting deadlines. Or if the respondent rate high in the statement punctuality in meeting deadlines, then the respondent will also rate high in speed of returning phone calls. So that's reflective latent variable. For the formative latent variable, according to Holland 1999, indicators can have positive, negative, or zero correlations. So in this case, these three indicators will affect life stress. Say, for example, if you lost a job, then your stress in life is very high. Or if you will experience divorce, or if you are divorced with your partner, then it will cause you a stress in your life. Or if you meet a recent accident, then of course you will experience stress in your life. Okay. Then these three indicator statements are not redundant. So they are not highly correlated. Meaning, if you experience job loss which causes you stress, it does not necessarily mean that you also experience divorce. Because you can be stressed because of job loss alone, even without experiencing divorce or recent accident. In the same way, you will feel stressed because of the recent accident without necessarily experiencing job loss or divorce. Okay, so that is formative latent variable, which is non-redundant or not highly correlated, and it is the indicator statements which affect the latent variable. Okay, now let us have this exercise. We are going to identify this as reflective or formative. Okay, so our latent variable given is drunkenness or drunk. Our indicators are can't walk straight, smells alcohol, slurred speech, dizziness, or slow reaction. Now you're going to identify, is it the drunkenness that will affect or will cause, is it the drunkenness that will cause you to not to walk in a straight line, for you to smell alcohol, for you to experience slurred speech, dizziness, and slow reaction? Or is it the slurred speech, dizziness, and slow reaction will tell you that you will affect your drunkenness? Okay, obviously, it is drunkenness that will cause these indicators. Therefore, it is a reflective latent variable. How about this one? Drunkenness is the latent variable and indicators are beer, wine, and liquor. So, is it drunkenness that will cause beer? Or drunkenness causes wine? Or drunkenness causes liquor? Or the other way around, beer causes drunkenness, wine causes drunkenness, and liquor causes drunkenness? Of course, it is the indicator that causes drunkenness, therefore it is formative latent variable. So in this case, even though beer alone causes drunkenness without wine and liquor, okay? Or wine alone causes drunkenness even without beer or liquor. So the indicators are non-redundant or not highly correlated. So that's formative latent variable. So maybe let's skip these two examples. Another reflective latent variable, and this one is also another formative latent variable. So we have here references from Diamantopoulos and Winkhofer in 2001 on how he decide whether it's reflective or formative latent variable. Fornell and Buchstein in 1982, Rossiter in 2002, Chin in 1998, and Jarvis et al. In 2003. So this is actually from Derek Ong lecture on Smart PLSM Notes, April 2017. Okay, let's now proceed to the measurement component. Take note that there are two distinct models in our structural equation modeling. We have here the measurement component and the structural model. So in the measurement component, it actually involves the convergent validity and the discriminant validity, as well as the reliability coefficients of our variables. Convergent validity signifies that a set of indicators represent one and the same underlying latent variables. It is the extent to which indicators of a specific latent variable converge or share high proportion of variance in common. That's according to Hensler et al. 2009. Then, according to Koch in 2015, a research instrument has good convergent validity if the indicators or the questionnaire items associated with each latent variable are understood by the respondents in the same way as they were intended by the designers of the indicators. Normally, when we develop research instrument in our survey, we have to make sure that the understanding of our respondents on the questions are the same with our understanding as the developer of the questionnaire. So it is the convergent validity that will measure that specific criterion in our in the quality of our instrument. So that's convergent validity. Now for discriminant validity, according to Koch 2020, a measurement instrument has a good discriminant validity if the items with each latent variable are not confused by the respondents. So in terms of their meaning, with the question statement associated with latent variables. Now for the reliability coefficients, the degree to which an instrument measures the same way each time it is used under the same condition with the same subject. Okay, so these are the measurement components of our instrument that will be used in structural equation modeling. Basically, we need to establish first the measurement component such that our statements or our variables meet the required minimum convergent validity values, discriminant validity values, and reliability coefficients before we proceed to structural model. We need to establish first that our instrument is valid, our discriminant validity is, or our instrument has discriminant validity and it has a acceptable reliability coefficient before we will proceed to the development of the model under the structural equation modeling. So in this case, we are using mediation analysis as an approach of we are using mediation analysis using structural equation modeling approach. Okay. Now, before we proceed to our lecture on convergent validity, reliability, and discriminant validity, I would like to advise everyone to download the free 90-day trial version of Rpls because we will be using Rpls, a software that will compute the discriminant validity, convergent validity, and reliability coefficients. So just type Rpls in the Google search tab and then it will lead you to a suggested website warpls.com. Then you click that suggested link and then after clicking that link, it will lead you to this page showing the Rpls scatter diagram. And then if you are going to scroll down, you will see there the current stable version 0.0. You will be downloading the current stable version 7.0 and just click. There are options on how to download. You will click Google Drive, you will click Microsoft OneDrive, you will click Southern USA, you will click download.com, you will click Google Drive, Microsoft OneDrive. So I suggest click down from download.com, then it will redirect you to a website, download.com or Microsoft OneDrive, wherein a button download for free will be reflected in your page. And then click that one, then you click everything there, click next, next, until you reach finish. Because once it is finished, then okay, it will install successfully the Rpls. Okay. Now let's proceed to our next slide. How to assess the convergent validity using Rpls. Okay. Okay. I would like to acknowledge Professor Amora, Johnny Amora, for his lecture on structural equation modeling, which I attended on February 6, 2020. So how to assess convergent validity using Rpls? So the following are being used: indicator loadings, cross loadings, average variance extracted, this is variance, or AVE. According to Hare et al. In 1987 and 2009, indicator loading represents the relationship between latent variables and their indicators. Okay? The relationship between the latent variable and their respective indicators. The indicator loading criteria, okay, take note of this criteria in order for us to say that our instrument has convergent validity. So first criterion, indicator loadings should be statistically significant. That is, p value is less than 0.05. Second criterion, indicator loading should be greater than 0.5. Okay, the indicator loading should be greater than 0.5. And then the indicator loadings, the third criterion, indicator loading should be greater than the cross loading. So we have two terminologies here, the indicator loading and the cross loading. I'll show you later the difference between the two. Another, in order for you to say that your instrument has convergent validity, average variance extracted represents the proportion of variance in the indicators that is explained by the latent variable. It is recommended by Fornell and Larker in 1981 that in order for the instrument to have convergent validity, the AVE or AVE should be greater than or equal to 0.50. Okay? So how do you interpret your instrument if the AVE is 0.50, for example? Okay? It indicates that the latent variable is able to explain about 50% of the variance of its indicators. Okay? So that is how we interpret the AVE. Let's have a sample Rpls output and explain to you the difference between indicator loadings and the cross loading. Okay. So in this illustration, you have here cut 1, cut 2, cut 3, cut 4, cut 5, cut 6, cut 7, cut 8, cut 9, cut 10. These cut 1 to 10 are indicators or indicator statements of the variable cut. Therefore, these values here that I place inside a green box are called indicator loading. Now, cut 1, 2, 3, 4, 5, 6, and 10 does not indicate the variable PPES or perceived peer support. Therefore, the values here that I place inside a red box are called cross loadings of PPES because the cut 1 to 10 do not reflect or do not measure perceived peer support. That's why these values are called cross loadings, while cut 1 to 10 measure confidence in using technology. Therefore, these values are called indicator loadings. So that's the difference between indicator loading and cross loadings. Let's look at this result from Rpls. Okay. So inside the green box, as I mentioned earlier, are the indicator loadings. Then I placed here inside the red box are the p-values of these respective indicator loadings. Observe that the p-values in the red box are less than 0.05. Okay? In fact, it's less than 0.001. What does this mean? It means that the indicators of the latent variables are statistically significant. Okay? Number 2. Observe the indicator loadings inside the green box are large. Okay? According to Hare et al. 1987, 2009, it is greater than 0.05. Therefore, it tells us that the instrument have convergent validity because our criterion is the indicator loadings should be greater than or equal to 5. So our values here are greater than 0.5. The indicator loadings inside the green box are higher than 0.5. So it tells us that there is a convergent validity in our instrument. Then number 3, cross loadings are small. So if you look at these values, the cross loadings are small value. Okay? Close to 0 basically. Because this statement's cut does not reflect that of PPS, or this statement's cut 1 to 10 does not measure CVB. That's why their cross loadings are small compared to their indicator loadings, which are large. Then the AVE in the blue box are large, as recommended by Fornell and Larker in 1981. it should be greater than or equal to 0.5. So as you can see, the AVE of COT is 0.618, the AVE of PPS is 0.628, and the AVE of CVB is 0.635. So they meet the criteria greater than or equal to zero point 0.5. Now, to summarize, the results 1 to 4 tells us or will indicate that the latent variables in our uh, model are or have convergent validity. Now, the values here in this table are actually computed by Rpls. So you just all you have to do is just input the data and then click the button, the command buttons, then Rpls will do the computation. Later, we will show you how to operate the Rpls. Let's proceed to how to assess discriminant validity of the instrument using Rpls. By the way, there are two approaches in assessing discriminant validity. So number one, to have discriminant validity, the square root of the AVE, or the square root of the average variance extracted of each construct, should be greater than its correlations with other constructs. That's according to Fornell and Larker in 1981. Another way in measuring discriminant validity is through the HTMT, or the heterotrait monotrait ratio of correlation by Hensler, Ringel, and Sarsdet, 2015. It is best discriminant validity if it's less than 0.85. It's good discriminant validity if it's less than 0.90. Let's have a sample output from Rpls. Okay, so observe the values in the red box and the green box. The diagonal elements inside the red box are the square root of average variance extracted. This one, 0.786, 0.792, 0.797. These are the square roots of average variance extracted. While the values in the off diagonals, the green, the ones inside the green box, are the correlations among the latent variable. Okay, correlations among the latent variable. So correlation between PPES to COT is 0.513. So there is a positive correlation, a moderate or high positive correlation. Then correlation of CVB to COT, correlation of CVB to PPES. And observe here that the p-values of these correlations are less than 0.001. So it tells you that there is a significant positive correlation among the variables. Okay, the p-value is less than 0.001. Number two, for discriminant validity, the square root of AVE should be greater than the correlations. Okay, so observe that all the square root of AVE values are greater than the correlation values. All the values in the red box are greater than the values in the green box. So it tells you that the table reveal, or the data in the table reveal, that COT, PPES, and CVB have discriminant validity. Okay. Let's proceed to assessing reliability using Rpls. There are two measures of reliability, the Cronbach alpha and composite reliability. A measure of internal consistency, that is how closely related a set of items are as a group. It is considered to be a scale or a measure scale of reliability. It is the lower bound, hence it underestimates the true reliability, according to Peterson and Kim 2013. Now, according to Peterson and Kim 2013, composite reliability is an alternative to Cronbach's alpha. Okay? Then it is usually calculated in conjunction with structural equation modeling. That's according to Peterson and Kim. Then Fornell and Larker 1981 mentioned that composite reliability is always higher than Cronbach alpha. Here are the set threshold value in measuring composite reliability and in interpreting composite reliability and Cronbach alpha. Both of these are measures of internal consistency of your instruments. So conservative criterion, Cronbach alpha should be equal to or greater than 0.7. That's according to Fornell and Larker, 1981, Nunnally, 1978, Nunnally and Bernstein in 1994. It will be relaxed criterion if the composite reliability should be equal to or greater than 0.7. Composite reliability coefficient is usually higher than Cronbach alpha. That's Fornell and Larker, 1981. More relaxed criterion, Cronbach alpha should be 0.6 or higher. That's according to Nunnally and Bernstein, 1994. Okay, so these are the set, the 0.7 and 0.6. So if your value does not reach 0.7, as long as it's greater than 0.6, then that's still acceptable. So more relaxed criterion by Nunnally and Bernstein, 1994. Let's look at these values or output from Rpls. Okay, observe the values that are boxed in red. So the composite reliabilities of COT is 0.946, 0.872 for PPES, and 0.894 for CVB. The Cronbach alpha of COT and PPES and CVB are 0.931, 0.800, 0.848. So, the composite reliability and Cronbach alpha are large, greater than or equal to 0.7 as recommended by Fornell and Larker 1981, Nunnally and Bernstein 1994, indicating that the latent variables can generate reliable scores when they are used to measure COT, PPES, and CVB. So those are the measurement component which were actually discussed by our previous speaker during the day 1 and day 2 of our webinar series. So convergent validity, discriminant validity, and reliability coefficient. By the way, I would like to acknowledge University of San Carlos South School for hosting the webinar on quantitative research. The speaker was Professor Johnny Amora, and the Vice Redac, that's Visayas State University Research Center, hosting the CFA SEMS webinar, whose speaker is Professor Christopher Leones. Of course, to BMTS for together with DepEd Mandaloyong, Marikina, for coordinating together in holding this webinar on factor analysis. Now, I'm going to show you a sample research paper of my students entitled The Mediating Effect of Confidence in Using Technology on the Relationships Between Perceived Peer Support and Computer Value Belief. Evidence from VS Isabel students. So they were actually BS Ed Math that time when we made this paper. And in fact, the paper was presented during the International Multidisciplinary Research Colloquium in 2021, specifically on August 10 to 11, 2021 via Zoom. Okay. The research framework of the paper or the study is that the mediating variable is confidence in using technology, which mediates the relationship of perceived peer support and computer value belief. So it was reflected earlier, some sample Rpls output, the computations of the convergent validity, reliability coefficients, and discriminant validity. So in this structure, we have 4 hypotheses. Hypothesis number 1 is that perceived peer support positively related to computer value belief. Okay, there's one here, the 2 variables at the bottom of the triangle. So perceived peer support is positively related to computer value belief. Then hypothesis number 2, perceived peer support is positively related to confidence in using technology. So the left side of the triangle. Hypothesis 3, confidence in using technology is positively related to computer value belief. So the right side of the triangle. So we have here hypothesis 1, hypothesis 2, and hypothesis 3. What is hypothesis 4? It is now the mediation effect. So hypothesis 4, confidence in using technology mediates the positive relation between perceived peer support and confidence in using computer value belief. Okay, so that is now the mediation effect. That's the hypothesis. Again, that's confidence in using technology mediates the positive relationship between perceived peer support and computer value belief. Okay, so that's our hypothesis 4. Now, we have here sample of 687. I'm sorry, this is typographical. N is equal to 687. Okay, so we have your male, female, age, your level, and course. We have here figure 2, the inverse square root method in determining the minimum required sample size, and the gamma exponential method, which tells us the minimum required sample size, which is generated by Rpls. So basically, you see, according to the inverse square root method, the minimum required sample is 76. While according to gamma exponential method, the minimum required sample is 62. But we have 687 sample. This is typographical error. That's 687 sample, which is more than the required sample size. Okay. Then the model fit indices. So these are the model fit indices and the structural equation modeling that tells you that our standard values or our values of APC, ARS, AARS, AFVIF, AFVIF, Teninho's goodness of fit are of acceptable values. They meet the standards, the minimum required values, telling you that the structural model is good to go. Okay. Now let's look at the measurement model. So here is now how we are going to present our paper, reflecting the indicator loadings, the AVE, composite reliability, and Cronbach alpha. So this is now the indicator loadings of the measurement component of the perceived peer support. This is the measurement component of the confidence in using technology, the measurement component of computer value belief. Okay. Now you can see that the indicator loadings are above 0.5, so acceptable. Then the AVE, see, composite reliability, and Cornbach alpha are of acceptable values greater than 0.6. Okay. That's how we present our measurement model. So this indicates that we are good to go. The measurement models tells us that our Latin variables are okay. So we will now proceed to the structure equation modeling. Then we have here the square root of AVE coefficients in table 4, that the diagonals are greater than that of off diagonals. The square root of AVE are greater than the correlation coefficients. Okay, that's table 4. Then table 5, the mediation model. The mediation model is that COT mediates the relationship between PPES and CVB. And this one here are the beta coefficients and the respective p-values. So for the PPES to COT, the beta coefficient is 0.53, the correlation between two variables, and it is statistically significant with p-value less than 0.01. Then the beta coefficient of COT to CVB is 0.44, and it is statistically significant with a p-value less than 0.01. And of course here, the PPES to CVB, the beta coefficient is 0.29, statistically significant with p-value less than 0.01. Take note, this is the effect of PPES to CVB is reduced because we introduced the COT. Okay. Then the parameter estimates of the model. So this is already the structural equation modeling. By the way, this is the partial least square, structural equation modeling being used in this research study. Okay. Hopefully, in our next webinar, we will be conducting a webinar on partial least square structural equation modeling, because what I am presenting here is only the factor analysis part of the structural equation modeling. So hopefully in our next webinar, we'll focus on structural equation modeling. We will be inviting another set of speakers to do the lecture on structural equation modeling. So as you can see, the beta coefficients of our hypothesis, so we have here the three hypotheses here: hypothesis 1, hypothesis 2, hypothesis 3, and hypothesis 4. Beta coefficients and their corresponding p-values and their standard error. It shows here that all our hypotheses, all our values are statistically significant with its corresponding effect size. Okay, so we will just discuss this more on our next webinar. Okay. And also, we have here terminologies: total effect, direct effect, and indirect effect, which are terminologies under structural equation modeling. So I'm just showing you that our model, this one here, the mediation model, is actually supported, showing that our p-values are less than 0.001. Okay. So another sample of research paper published in Travel, Behavior and Society Journal, Index in Elsevier or by Elsevier, entitled Young People's Perceived Service Quality and Environmental Performance of Hybrid Electric Bus Service, authored by Ziol Hakemunem and Tijib Nuor. Okay. This is their conceptual model. The service quality measured by bus tangibility, bus drivers' quality, and empathy affects customer satisfaction. And customer satisfaction affects life satisfaction. Then environmental performance affects customer satisfaction. Customer satisfaction affects life satisfaction. So this is an example of structural equation modeling. In my case, the one that I presented earlier, which is in a triangle form, we introduce a variable called mediation variable or mediating variable. So that's basically the mediation analysis. And we are using there in the model the structural equation model approach. Okay, these were the findings, the measurement component. Okay, the measurement component of this model, showing that the indicator loadings are higher than 0.6. And as you can see along this part here, this statement is being dropped. Why it's being dropped? Because it's less than 0.6, less than the standard, less than the acceptable value 0.6. So it is reflected in the table 2 of the research paper that statement number 3, no disturbing noise from engine when sitting inside the bus, is being dropped. Okay. This is the divergent validity analysis. And this is the descriptive statistics among latent variable and correlations. So you have here the correlations among latent variables. And then these are now the beta coefficients, the indicator loadings of the statements to its respective latent variable. So you can see it's greater than 0.6, greater than 0.6. So I mean to say these indicator loadings measure bus tangibility. These indicator loadings BD to B4 measure bus driver's quality. Then EMP 1 to 5 loads to empathy. EP1, EP2, EP3, EP4 loads to environmental performance. Then CS1, CS2, CS3 loads to customer satisfaction. Then LS1, LS2, LS3, LS4 loads to life satisfaction. And then they have here the correlations among the latent variables. So we have here 0.6, 0.346, 0.125, 0.3235. Then for customer satisfaction to life satisfaction, it's 0.309. Okay, so this is now the estimated structural equation model of the papers presented. And so this is now the structural equation model, the summary of hypothesis. So it is only the hypothesis 2 which is not supported. Bus driver quality and customer satisfaction. So this one here, bus driver quality and customer satisfaction hypothesis is not supported. Then we have partial equation model or partial mediation, bus tangibility, customer satisfaction, and life satisfaction. Bus tangibility, this portion here, this path here from bus tangibility to customer satisfaction, life satisfaction as partial mediation. Then no mediation is bus drivers, quality, customer life satisfaction, and life satisfaction, no mediation. So from this path here, bus driver to customer to life satisfaction, the hypothesis here is not supported. Considering also as well that the hypothesis of bus driver quality and customer satisfaction, this hypothesis here is not supported. Okay? So basically, the path bus driver quality to customer satisfaction and life satisfaction is also not supported or has no mediation. Okay, so thank you for listening. Let us now proceed to our workshop using Rpls. Okay, it will be my student Erica May Quabo, who is now BS Ed Math 3 at Visayas State University, Isabel, who will show you how to use Rpls in computing all of those values on divergent validity, convergent validity, discriminant validity, and reliability coefficients. Now, I would like to invite everyone to listen very carefully in the workshop because you will be presenting after the workshop. You will present your outputs and the interpretation or analysis of those values. Okay, so here are your expected outputs after the breakout session. You will present number one, the convergent validity in this table. This one here, then the discriminant validity, this table. You will present the reliability coefficients, this table, and also the beta coefficients, this table, as well as the results of inverse square roots method and gamma exponential method. Again, please take screenshots or take a picture on what you are going to present. The convergent validity, please screenshot. Then discriminant validity, please screenshot. Then the reliability, please screenshot. Then beta coefficient, please screenshot. And then the results of the inverse square roots method and gamma exponential method, please screenshot. Okay, so we will now proceed to the presentation using Rpls in CFA SEM by Miss Erica Quabo, BS Ed Math 3, Visayas State University, Isabel, and member of the Community of Math in those trusts. Okay, kindly open your Rpls because our facilitator, Sir Rinaldo, will now assign you to your respective breakout sessions. Okay, that's all, and thank you so much.
All right, so I hope everyone has taken the screenshots of the things that we are going to accomplish. So meron po tayong 5 required outputs later on. I hope everyone has taken screenshots. Now, I will be presenting yung instructions as to how we are going to use the software by Miss Erica Quabo.
Hi, good day. I hope you're doing well. Because today, I will show you how to conduct a structural equation modeling or SEM analysis using the WARP PLS software. For this video, I will be using the data gathered from the study The Mediating Effect of Confidence in Using Technology and the Relationship between Perceived Peer Support and Computer Valuability. So, let us start. Just click Proceed to use software. The first step is you need to click Proceed to Step 1. Then, Create Project File. After that, you will see this box, and this asks you to provide a path and a name of your project file. For this, I will name it SEM. Then, Save. Click OK to proceed Step 2. Then click Proceed to Step 2. For Step 2, Rpls software will read a raw data file. Click Read from File. Then, this box will appear, and this asks you to put your data file here. So, I will put the data of the research here. Then, click OK. This message will appear. Then you will click OK to import your data. Then, you will need to wait for a while because the software is still importing the data. Let us wait. Then click Next and Finish. Click also OK. After the process, you will see these data that have been imported. So, accept this data by clicking Yes, and then we can now proceed to Step 3. Click OK. Then, click Proceed to Step 3. In Step 3, the software will pre-process the data. It will check and correct missing values, zero variance problems, identical column names, check for rank problems, and standardize the data. Click OK button. Then click OK, and this table will appear. And this is now the standardized data provided by the software. And I will accept it by clicking Yes. And now we can proceed to Step 4. Click Proceed to Step 4. We will define now the STEM model. We will create here a latent variable which is going to be reflective. We will create a latent variable. First is the confidence in using technology or CUT. Just click CUT, then add. And it is going to be reflective. Save the latent variable. Then the next variable to be created is the PPES or perceived peer support. Then add. It is also going to be reflective. Save latent variable. Then the last variable is the CVB or computer value belief. CVB. Then let's add. it is also going to be reflective, then save latent variable. After that, we will create direct links between the variables. PPES, or perceived peer support to confidence in using technology. Then confidence in using technology to computer value belief. Perceived peer support to computer value belief. With this link, the mediating variable is the confidence in using technology. The independent variable is the perceived peer support, and the dependent variable is the computer value belief. These links will help to know if perceived peer support is significantly associated with CVB, or computer value belief, if perceived peer support influences the mediating variable confidence in using technology, if confidence in using technology influences computer value belief, and if COT, or confidence in using technology, is a mediating variable between perceived peer support and computer value belief. After creating a link between these variables, we will save the model and close, and the software will create a model structure in preparation for the analysis. So click OK. Now we can now proceed to step 5, which is to perform the analysis. Then click Perform Some Analysis. And we can now view the results. And for today, I will be showing the results of the study I've mentioned earlier. These results are the inverse square root and gamma exponential methods, the model fit and quality indices, the item loadings, AVI, and reliability of the variables, the square roots of AVI coefficients and correlation coefficients, the mediation model with parameter estimates, and the parameter estimates of the mediation model. First, let us find the result of this one, the inverse square root and gamma exponential method. This result shows the minimum sample size required in the analysis, and we will know if the sample size we use in the analysis is enough. In the top, view general result. The sample size used in the analysis is 687. Let us find out if this sample size is enough. So, let us click the main menu of the software, then click Explore. Click Explore Statistical Power and Minimum Sample Size Requirements. After clicking, you will see this result. We need to change the minimum absolute significant path coefficient by the minimum value of our path coefficient. The minimum value can be viewed in our mediation model. This one, and this one. Or it can be viewed in the tab Path Coefficients and P-Value. This one. With this result, the minimum path coefficient is 0.287. So we will copy this and enter it here to find our minimum required sample size that can be used in the analysis. So press enter and now we can see the result of the gamma exponential method and the inverse square root method. The gamma exponential method minimum required sample size is 62, while the inverse square root method minimum required sample size is 76. As a result, the needed minimum sample size ranges from 62 to 76. Since 687 sample size is used in the analysis, this means that the sample size is sufficient enough for the analysis. It is an enough evidence that the structural model results are highly acceptable. Next, let us find the model fit and quality indices in the software. We can find this result in this area. The view general results. This one. The model fit and quality indices. So, the required p-value for the indices average path coefficient, average R-squared, and average adjusted R-squared to be acceptable, it must be equal to or lower than the value of 0.05. Moreover, for indices average black beef and average full collinearity beef, the required value must be lower or equal to 5 to be acceptable and lower or equal to 3.3 to be ideal. For the tenant house goodness of fit, the criteria are small if it is equal to or more than 0.1, medium if it is equal to or more than 0.25, and large if it is more than or equal to 0.36. The results shown in the model fit and quality indices shows that the estimates of the variables are within the acceptable range. The p-value of the average path coefficient, average R-squared, and average adjusted R-squared is acceptable with a value of 0.001. Moreover, the AVIF or the average black beef and the average full collinearity, the results are less than 3.3, which is ideally acceptable. For the last index, the tenant house goodness of fit, it shows a result of large. Therefore, the model fit and quality indices meet the criteria. So next, let us find the item loadings, the average variance extracted, and reliability of the variables in the Rpls software. For reliability measures to test the reliability of the variables, CR or Composite Reliability and CA or Cranbach Alpha were used. We can find this result in this area. The view latent variable coefficient. The value of composite reliability and cramback alpha must be equal to or greater than 0.7 to pass the criteria of having a good reliability. And for the results, the three variables satisfy the reliability test. On the other hand, to assess the convergent validity, item loadings and average variance extracted were analyzed. The recommended value for convergent validity, the item loadings, and the average variance extracted is equal to or greater than 0.5. We can find the item loadings here. The view indicator loadings and cross loadings. Then click view combined loadings and cross loadings. The value having a parenthesis are the item loadings. So this is for the confidence in using technology, for the perceived peer support, and for the computer value belief. And as we can see, the values are greater than 0.5. And for the average variance extracted, we can find it in this area. The view latent variable coefficient, this one. And as we can see, the values of the three variables are also greater than 0.5. Since ABI and item loadings are greater than the recommended threshold, so it satisfied the acceptable validity. Next, let us find the square roots of ABI coefficients and correlation coefficients in the Rpls software. These results measure the discriminant validity of the instrument. We can find this result in this area. The view correlations among latent variables and errors. Then click view correlations among latent variable with square roots of ABIs. Then these are the results. The diagonal elements or the values inside the parentheses are the square root of ABIs. And in order to have a discriminant validity, the square root of ABI of each construct, the CUT, the PPES, and the CBB must be greater than its correlation with the other constructs. The results revealed that the variables have a discriminant validity because the correlations are greater than the correlations of its constructs. Next, let us find this model in the Rpls software. Well, after performing step 5, this model will appear, this one. The mediation model with its parameter estimates, and it shows us the significant mediating effect test. For the last result, this one, the parameter estimates of the mediation model, I will show you how to find the path coefficient or the symbol, the standard error, p-value, and the effect sizes. For the path coefficient and p-value, we can find it here. The view path coefficient and p-value. This is the path coefficient and this is the p-values. For standard error and Cohen's effect size, we can find it in the area view standard errors and effect sizes for path coefficients. This one, standard error and the effect sizes. For effect size, the criteria are 0.2 for small effect size, 0.15 for medium, and 0.35 for large effect size. Always remember that the list of hypotheses in your table, this table, should match with the hypothesis indicated in your research model, this one. And for the indirect effect of the table, this one, you can find the values in this area by viewing indirect and total effect, this one. Just transfer the values here into this table. Then, for the total effect, you will get the value by using this formula. Just calculate so that you can get the total effect. Then, after you solve the total effect or after completing the table, this table will now help you to know if your hypothesis is supported or not. And for these parameter estimates, the result shows that all of the hypotheses here are supported.
All right, so that's it for our demonstration on the use of Rpls software. Now we will proceed with our breakout sessions. So for our breakout session, we wanted someone to have the software installed on your devices as well as share the screen later on. So I'll be opening the permission for you to share the screen later on. Also, I'll be sending the link as to where we are going to get the data. So right now, at the moment, please check the chat box and you will be able to see a Google Drive link there. Please download the two data sets there, but we are just going to use the room 1 data set labeled. The other one, you can use that for your practice after this session. So again, please go to the link that I have sent on the chat box and download the room 1 dataset. Okay po, can I see heart reacts po once you are able to access the Google Drive link? Kindly press heart react in the Zoom if you are able to access the Google Drive link that I have sent. So for our live viewers in the YouTube, I will also be sending this in a few minutes. So for now, kindly download our data sets for our Zoom participants. Now, can I see thumbs up reaction if you are able to download the data already? May mga nakita na po akong nag-heart react, so they are able to access. Now, if you are able to download the data for room 1, kindly press the thumbs up reaction. Yeah, let's wait for others. You can use the raise hand button po if you are not able to access the data para po matulungan namin kayo. Ayan, meron nang nag-thumbs up. Ayan. How about the others po? Are you able to access the data and download it? Excel file po siya. And then if you are able to see the drive link, nakalagay po doon room 1. Only room 1 po kasi yung isa po nating facilitator is currently having trouble with her internet connection. So we will just be having one group for now. All right, so I'll now open a breakout session for all of us. So please enter, and whoever po is willing to share their screen for everyone for us to accomplish our outputs required for the day, then maganda po yun. So I'll be opening it now. You can join the room 1. So room 1 data po ang gagamitin natin. Yan, please join room 1. For our live viewers po, please wait for a while. I'll be sending the dataset link in the live session for about 2 minutes from now. So just click po yung join room for you to be able to join the breakout session. We still have some participants who are not able to enter. Please enter the breakout session room. Ayan. So let's wait po. I hope you are also able to take a screenshot of the things that we are going to accomplish because we are required to accomplish those 5 things listed earlier. Again, please join the breakout session so that makapag-exchange po tayo ng ideas. It would be better if you have downloaded the free trial of the Rpls software so that pwede po nating itry kung paano natin gamitin yung software. All right, so for our live YouTube viewers, stay put lang po tayo kasi we are going to have a breakout session right now. So just stay there and I'll be sending the link for the data set, and you can also try this while we are waiting for the presentations of each group. Thank you very much. Sir Ricky, Ma'am Cecil, and Ma'am Maridel, you can also enter yung ating breakout session para po mapakinggan po natin at makita po natin yung process because someone is already starting the presentation there. Thank you so much. To our YouTube live viewers, na-send ko na po sa comment section, live chat, ang materials that we needed for our activity. So if you would be able to download the free trial of the Rpls software, then please do so para po matry nyo rin pong gawin. And to our remaining participants right now in the Zoom, you can enter the breakout rooms para po makapag-participate tayo doon. Thank you very much. Ma'am Maridel, Sir Ricky, Sir Ananias, you can enter po yung ating room 1. A pleasant morning again to our YouTube live viewers. Please wait for a while po. Nagkakaroon po kami ngayon ng breakout sessions regarding our session 3. So if you may also want to try and use the Rpls software, please do so. Na-send ko na po kanina sa ating live chat ang attendance link as well as the materials needed. So nandoon na po lahat yon. Just feel free to access the links. I believe makikita nyo po yung comments doon. And also, please take note na kailangan po ang inyong attendance. So if you are not able to have your attendance yet, please access the attendance. It's also posted on the comment section. Again, good day to our YouTube Live participants. We are still in the breakout session at the moment. So, if you would wish to take your break for now, you may do so. Balik po tayo in 10 more minutes. The presentations will be done after that kung ano po yung outputs natin. Thank you very much. Again, good morning to our YouTube Live viewers. Nagkakaroon po kami ngayon ng breakout sessions. So please wait for a while. For about 5 minutes, they are going to finish and be back here in the main session. Kasi ngayon po, nasa breakout sessions po ang ating mga participants. So take your water break po muna or share break while we are waiting. Thank you very much. Yan, mukhang nagkakahiyaan po tayo. Siguro, Sir David, you can tell us a little something that you know about the presentation that we've had, considering na nakuha mo naman po yung mga process siguro. Sir Dolph? Okay. Yeah. Yan. Go ahead, Sir Dolph.
Okay, hello po. Okay, I will try to help Sir David present the output habang malakas pa yung signal na nawawala. So you can see the inverse square root method, Sir David. Ano po yung value sa amin? Blurred po kasi on my yung value. Baka dahil sa signal. Yung inverse square method, minimum required sample size is, ano po yung value, sir?
79.
79 po yata siya.
Yes, sir.
Yung inverse, yeah, sa gamma, sir, is 66 or 88?
66, sir.
66 po siya yata.
Yes, sir.
Yes po. So meaning, minimum sample size are 79, 66 according to inverse square root method, gamma exponential method respectively. So, yung set po na ginamit natin, 687 po. So that means
Alright. Mukhang nahihirapan po sa signal si sir.
So, sir, nawawala po pag magsasalita actually.
Yan, sir. Clear
Okay,
na
so
po
let's
siya,
proceed
sir.
to the next slide, Sir David. Sige, dito ako sa medyo labas. Okay. Yan. So, you see the Cronbach alpha of POP? Sir David, pwede po kayo mag-mention ng mga values. Ako po yung magsalita kung ano ang i-mention na value. Kasi blurred po from my end. Yung composite reliability po ng...
Okay, again?
Yes po, sir. Go ahead, sir. Cronbach alpha.
Cronbach's alpha, we have for the CUT 0.931, and then for PPS, we have 0.843, and then for MSRLT, 0.890 for the Cronbach's alpha.
Okay, so more than po siya ng minimum value na 0.7. That means to say po, acceptable po yung yung variables. How about po sa composite reliability, sir?
For the composite reliability, CUT 0.942, PPS 0.889, and MSRLT 0.910.
Okay po, so it's more than po the minimum value na 0.7. So that means to say, okay, acceptable po yung yung instrument in terms of reliability. Okay po, let's proceed to, may AVE pa po dyan, sir, average variance extracted.
Okay, average variant extraction. CUT 0.618, PPS 0.618, MSRLT 0.505.
Okay po. So value, base sa minimum relax is 0.5, the most relaxed is 0.5. So acceptable din naman po. Okay, let's proceed. Next slide, sir.
Oh, sorry. Okay, next slide.
Okay, nakita natin sa parenthesis, ano po yung tinatawag na interloadings. So as you can see, yung mga indicator loadings are greater than 5. Cross-loading natin ay maliit na values which are smaller than our indicator loadings.
Alright, mukhang nahihirapan po ulit si Sir Dolph sa kanyang signal. As we have heard earlier, yan daw pong nandyan sa ating slides ay mga indicator loadings. And we can see clearly na mas mataas sila sa mga minimum values na 0.7. So, yung mga naka-parenthesis po, yun po yung aking nakita dyan. Siguro, sir, we could present the next part.
Tama po.
Ayan po, Sir Dolph.
Ay, okay. Sir Dolph.
Sige po, go ahead po ng next slide. Nawawala talaga ako ng signal. Thank you po.
Correlation.
Po, pakita mo yung nasa diagonal at saka sa off diagonal.
Diagonal, sir, no? So for correlations, for CUT, we have 0.786. For PPS, the same 0.786. And then for MSRLT, 0.711. That's for the correlation. For p-values, all variables obtained an exact 1 value.
That means statistically significant po yung natin, correlates.
Okay. Then the last, I'm sorry, the fake.
Sir, hindi ko na po nakikita dito sa screen share. Model na yung last structural model.
Here, sir.
Multiple circle. Pero actually, kung nakikita yung screen is sa internet.
Okay.
All right. I guess nahirapan po talaga si Sir mag-connect sa ating session. But ayan, hindi daw po nakikita masyado ni Sir yung shared screen because of the signal problem. So, makikita naman po natin clearly sa presentation ni Sir David that yung mga beta values po from PPS to CUT is 0.48 and then R squared there is 0.23 for the CUT, ayan. And then from CUT to MSRLT, ang na-compute po na beta coefficient is 0.5. And ang R squared naman po sa ating MSRLT is 0.46. Now, from PPS to MSRLT, ang beta coefficient naman po na na-compute is 0.28. Again, thank you very much, Sir David, for sharing your screen as well as for volunteering on how we have able to arrive in this output. Thank you very much po and job well done po. Congratulations po, sir. Before we go with the closing remarks, do we have some questions po or concerns? No. While we are also waiting for Sir Dolph, ayan, you may go ahead now. So thank you po, sir, for the signal. So I would like to ask some volunteers from our Zoom participants and YouTube live viewers for any messages to our organizers, considering that this is our last day. So baka po meron tayong mga messages or any commendations or suggestions to our organizers. Maybe I could ask as well from Sir David kung ano po ang kanyang message for the organizers. Sir? Or any volunteer din po, you may use the raise hand button. Let's start with Sir David since si Sir yung nakita ko na active all throughout the sessions from day 1 up to the last day. Talagang nakita po natin yung interest ni Sir sa factor analysis. No? Siguro let's call one from Luzon, one from Visayas, and one from Mindanao. Just messages po. Pwedeng suggestions or pwede naman pong comments or maybe some good messages for our organizers. Sir David, you can unmute yourself po.
Sure, sir. Thank you, sir, for giving me the opportunity to express my gratitude to the entire team. And I would like to congratulate everyone on doing such a great job of developing a new project plan for your group. All the best for the math team, and the extra time you've been putting in on this has really paid off. And I believe that you have presented an ambitious and attainable set of goals for your team and for the rest of us. as educators. So thank you very much po for this, for you and your staff's hard work po, and we look forward to future projects with you po. I hope I could be part of it in the future. God bless everyone.
Thank you so much, Sir David, for those warm words. Nakakatuwa pong isipin that kahit marami tayong struggles online, we are able to finish this 3-day seminar workshop successfully. Alright, siguro po hingin ko rin po ang reaction from the Visayas group naman. Anyone from the Visayas group? Yan, marami tayong mga participants from the Visayas group who would like to give some messages as well. Yan. Let me just read some comments from the chat box. Yan. From Ma'am Maria Chona Futalan, hoping for more free virtual seminars. Thank you to all the speakers and to the organizer. Yan. You can also send your messages po. Ayan, meron atang nag-open ng microphone. Miss Jennifer, do you have some messages for us and to our organizers? Ayan, mukhang napindot. Siguro, dahil meron na tayong from Visayas, one last reaction or comments or suggestions from the Mindanao group. Can I hear from Sir Joseph? Sir Joseph? Kahit short lang po na message. Ayan, mukhang nahirapan si Sir Joseph. How about Sir Nino? Is this Sir Nino? Yan, tama po ba? Ayan. So from the bottom of our hearts po, from the SDO Mandaluyong, Marikina, and Parañaque City, as well as the organizers of... Ayan, mukhang mayroong nag-o-open ng microphone. Just use the raise hand button po para I can recognize you. So maraming salamat po sa ating mga organizers, and we hope na kung hindi nyo po napanood yung mga sessions natin or gusto nyong balikan, available po ang ating mga videos. Recorded na po yan sa YouTube channel. Just visit MTM channel. Yun po ay capital letters lahat. M as in Mathematics Teachers of Mandaluyong. Capital letters po yan. Nandun na po lahat. You can review the sessions 1 to 3. Kung gusto po nating balikan yung mga procedures, kung gusto po nating balikan yung lectures ng ating mga experts. So, pwede po natin yan balikan anytime, anywhere in our MTM channel. Alright, I guess wala na pong hahabol sa mga messages. So, thank you very much again to all our participants. So, at this juncture, let us hear the closing remarks coming from the PIO for Public Schools. Let us welcome our PIO for Public Schools for the BMTS Incorporated, Ms. Rubilen Kionisala.
Good day, everyone. I'm Rubilin Esquinisala, an officer of the Basic Education Math Teacher Society. And it is a great pleasure for me to say a few words at the end of this seminar workshop. First and foremost, I would like to express my appreciation to the speakers, namely Dr. Craig N. Refugio, our Vice President for Research and Extension, to Professor Ray Ferdinand M. Gagani, our Vice President for Education, and to Dr. Rodolfo T. Onzo, our beloved President in Basic Education Math Teacher Society. We are so grateful for their valuable contribution and sharing their expertise for the 3-day seminar workshop. on conducting and interpreting factor analysis this 60th, 23rd, and 30th of October 2021. Also, my deepest gratitude goes to all who attended this seminar workshop and all the staff with the collaboration of Department of Education, Schools Division of Mandaluyong City, Marikina City, and Parañaque City who helped to make this event a successful one. This is not the first time that the BMTS conducted seminar workshops for free. This is part of the organization's purpose to encourage and stimulate excellence in mathematics and its application by conducting workshops and seminars for mathematics teachers. And I believe all the things that our speakers shared to us are very important and relevant to us. We learned a lot of things from this seminar workshop. We might even experience aha moments. And I hope that in the end, it is not just about what we learn and know, but what we do with what we know. According to Tim Sanders, in his quote, "Education without application is just entertainment." So let's apply what we have learned. And luckily, one of the purpose of the BMTS is to encourage and provide opportunities for the exchange of ideas and materials related to the instruction of mathematics by holding annual research conferences. And this coming January 27 to 29, 2022, we will have the 2022 BMTS International Research Virtual Conference. So, this is the time to show us what you've got and apply all the things that you have learned. Be one of us. Thank you and God bless everyone.
All right. Thank you very much for attending this 3-day national seminar workshop on conducting and interpreting factor analysis. And before we end po, I would like to invite everyone to open their cameras for our photo opportunity para po magkaroon naman tayo ng pictures together. Yan. Let me see those hardworking faces. Alam ko po tayo ay nasa weekend but we are still learning a lot. Yan. Sige po. Open po tayo ng cameras. I have 2 panels here so siguro po magbibilang na lang ako, no? Yan. Okay, wala na po bang hahabol for the photo? Magti-take na po ako in 3, 2, 1. Smile lang po tayo kasi hindi natin alam kung saan tayo nakabilang. All right. 1, 2, 3. All right. Isa pa po. Baka po hindi na isali yung iba. Okay. Wala na po bang hahabol? Yan. Biggest smile na po kasi last day na po natin. Okay. One more. 1, 2, smile. Okay. Yan. So, thank you very much po for participating and you are invited to attend the international research conference that would be held on January 2, 2022. Ang abstract deadline po natin ay November 15, 2021. So habol po tayo if we would want to participate in the said international conference. Yan. Again, this is your host, Sir Ray. Your certificates will be sent to you directly through your emails. I-review po muna namin yung attendance natin from day 1 to day 3. So thank you very much for participating. Have a good day and God bless everyone.